Hey guys, Mr. Holly here. Today we are looking at Lesson 5 of Module 5. And in this lesson we are going to start to look at chance experiments whenever you don't have equally likely outcomes. Like, what if your spinner had spaces, but the spaces weren't all the same size? Or the probability of coming up with one outcome is less likely than the probability of coming up with a different outcome. So we're going to start to look at how do we tell the probability if the chances are not equal. So, for instance, you have a table here that tells us about Jenna's grocery store visits. When Jenna visits the, farmer's market, not grocery store, this is the probability that she will purchase the following number of bananas. So, what's the probability that she buys exactly 3 bananas? Well, 3 bananas, 2/10, so 20%. You can say 2/10, or you can say 20%. We can say 2 out of 10, 1 out of 5. However, you can say it as decimal, fraction, or percent. What is the probability that Jenna doesn't buy any bananas? Well, 1/10 of the time, she gets fed up. She's like, I just buy these and they just sit there and rot. I'm not buying any this time. Just kidding. That's just what I do. Okay, so 1/10 of the time, or 1/10 of the time, or 10% of the time, she buys no bananas. What is the probability that Jenna buys more than 3 bananas? More than 3. So does that include 3? No. But it includes 4, 5, 6, 7, anything more than 3. So that would be 4 and 5 together, which would be 0.5 or 1/2. Or 50% of the time she buys more than 3 bananas. What is the probability that she buys at least 3 bananas? So that would include 3. So that's 4 and 5 and 3. So that's 7/10 or 70% of the time. What is the probability that Jenna doesn't buy exactly 3 bananas? So any number except for 3. Well, 3 is 2/10 of the time. 8/10 of the time she buys something different. 80%, fraction, 8/10. All right. Let's look at another example. Here, Jenna's husband, Rick, concerned about his diet. Me too, Rick. Me too. On any given day, he eats 0, 1, 2, 3, or 4 servings of fruits and vegetables. The probabilities are given in the table below. On a given day, find the probability that Rick eats 2 servings of fruits and vegetables. So that would be exactly 2. So if I look here, 2 is a 28/100ths is the chance, or 28% is it's equivalent. 28% is our probability. What's the chances he eats more than 2? More than 2. So that would be 3 or 4. So together, here we have 51/100ths. All I'm doing, I'm just adding these together because it's either one of those. 51/100ths or 51% of the time. The probability that it's 3 or 4 would be either of those, both of those added together. At least 2 servings. So that would be 3 or 4. And 2 would be included in that as well. So at least 2 means 2, 3, or 4. So any of those numbers. So let's add an additional 28/100ths here. You get 79/100ths. So the probability, 79/100ths or 79% of the time, Rick eats at least 2. Find the probability that Rick does not eat exactly 2 servings of fruits and vegetables. Well, 28% of the time he eats 2 servings. So that means the rest of the time, so all of the time is 100%, right? 28% of the time is when he does eat 2 servings. So the rest of the time, that other 72% of the time, he eats something besides 2 servings. So 72% of the time. All right, let's look at another example. Example 2. Lewis works in an office, and the phone rings occasionally. The possible number of phone calls he receives in an afternoon and the probabilities are given in the table below. All right, 1 phone call, 2 phone calls, 3 phone calls, 4 calls. Okay. Find the probability that Lewis receives 3 or 4 phone calls. So that would mean we're adding both of these together. 3 phone calls is 1/3, 4 is 1/9. Well, 1/3 is 3/9, so this is equal to 4/9. Find the probability that Lewis receives fewer than 2 phone calls. Fewer than 2, so that is 0 or 1, 1/6, 1/6. That's equal to 2/6, which is equal to 1/3. Find the probability that Lewis receives 2 or fewer phone calls. So 2 or fewer, so that's 2, 1, or 0. 1/6 plus 1/6 plus 2/9. All right, on this one, a couple different strategies here, but the best way is probably find the least common denominator, and we're going to do that by making it 18. 6 times 3 is 18, so that's 3/6, or 3/18, and this would be 3/18, and this would be 4/18. 3 and 3 and 4, that's 10/18, which is equal to 5/9. 5/9. All right, find the probability that Lewis does not receive 4 phone calls. Well, he receives 0 through 4 100% of the time, which is equal to 1. He receives 4 phone calls 1/9 of the time, so let's take away 1/9. And that means 8/9 of the time he receives something besides 4 phone calls. All right. When Jenna goes to the farmer's market, she also buys broccoli to go with her bananas. Find the probability that Jenna buys exactly 3 heads of broccoli. Well, 3 heads, 1/4. Right there it is. She does not buy exactly 3 heads of broccoli. Well, that's 100% of the time minus that 1/4 of the time when she does. It's 3/4 of the time. Buys more than 1 head of broccoli. More than 1 head, so not 0 and not 1, but 2, 3, or 4. So that would be 5/12 plus 1/4 plus 1/12. All right, I'm going to rewrite this as all 12ths, 5/12 plus 3/12 plus 1/12, and that's going to give me 9/12 or 3/4. Just found my common denominator here of 12. Okay, buys at least 3 heads of broccoli, so that is 1/4 plus 1/12. Well, 1/4 plus 1/12, that is 3/12 plus 1/12, which is 4/12, which is equal to 1/3. So 1/3 is our answer for D. All right. All we're doing here is we are just finding the amount that aligns with whatever outcome they're looking for. It tells us what portion of the time we get that outcome. And we're just looking through those. All right. Let's look at this example. Here we're looking at a clock. Think about how many sections does a clock have. It's 12 sections. So here red looks to be 1 section. This looks to be 2 sections. 1, 2, 3, 4, 5. That's 5 sections. 1, 2, 3, 4. 4 sections. Did we count them all? 4 and 1 is 5, 10, 12. Okay, so there's 12 sections. Write your answer as a fraction in lowest terms to find the probability that the pointer stops on the following colors. Well, red is 1 section out of the 12 sections of the clock. So the probability it lands on red, 1 out of 12. Blue is 2 sections. That is 2 out of 12, or 1/6. Green is 5 out of the 12 sections. And yellow is 4 out of the 12 sections, or we can simplify to 1/3. Find the probability that the pointer stops in either the blue or green region. So we are adding those together because that's either one. Either one satisfies our positive outcome. So blue and green. Blue is 2, green is 5. There are 7 outcomes. So, or excuse me, 12 outcomes. So 7 favorable outcomes, 12 possible outcomes, 7 out of 12. Find the probability that the pointer does not stop in the green region. Green is 5, so think about it as 100% of the time it lands in some region, minus the 5/12 of a chance it has of landing in the green region, and that's going to be 12/12 minus 5/12, which is 7/12. So our answer is 7/12, the chance it will not land in the green region. All right, go ahead and get to work on the problem set, and I will work those out for you in just a minute.